can write let alpha is equal to say a plus eta b, and beta is equal to c plus eta. We are given that mod beta is equal to 1. So we know the modulus of the complex number. Mod beta is equal to 1 will imply square root of beta is c plus eta d. So the real part is square plus imaginary part. This is what mod b is, and that is 1. Now if c square plus d square is 1, we can square both sides and write equation. So we can get this will further imply c square plus d square is equal to 1. Here we get this information from mod beta is equal to 1. So we will use this in calculation of this quantity. Now, what will be beta minus alpha by 1 minus alpha naught beta? Let us first calculate this. Quantity is beta minus alpha by 1 minus alpha naught. This thing can be written as, simply substitute the value beta plus eta d minus a plus eta b divided by, here I will have 1 minus, see this conjugate alpha naught will be a minus eta beta. Simply change this sign. So will be a minus eta b multiplied by eta b. It can be simplified. You can write this quantity in terms of a plus eta b. So we are writing the real part together, which comes c minus a real part, and plus eta b minus b divided by, the denominator will simply open it, so minus, and you multiply this will be AC, and minus eta square BD, so which can be plus BD because minus eta square is 1, and minus eta BC plus eta AD, eta BC eta AD. This thing can be written numerator as it is, C minus A and B minus B. Numerator will write as it is, and in the denominator we will write real and imaginary part separate. And denominator comes when I take the real part together, 1 minus AC minus BD like this, and imaginary part, so this will become positive plus eta, BC become positive, and AD becomes something like this. Now this is in the form of Z1 by Z2, the first complex number in the numerator, another complex number in the denominator, which we have written a plus eta b form. So now we can find modulus of this quantity. We were asked, therefore, modulus of quantity up there, beta minus alpha by 1 minus alpha naught. Okay. Here we go. Beta minus alpha by 1 minus alpha naught. So will be modulus of this quantity, modulus of C minus plus eta D minus B, D minus D minus D, and divided by AC minus BD plus eta time BC minus AD. This is simple calculation now. Since we know modulus of Z1 by Z2 can be written as modulus of Z1 by modulus. We will use this formula. Also, we have used another formula here, which we should write. What was that formula? That Z bar is equal to x minus eta y if z is equal to x plus eta, right? We have used this formula, we have used this formula. Now, okay, modulus of this means again the real part square, imaginary part square. So we are getting it c minus a whole square plus b minus d whole square divided by 1 minus ac minus bd whole square and plus bc minus ad whole square. Now it's simple calculation. So quantity comes out to be is c square plus a square minus 2ac plus, right, b square plus d square minus 2bd 4 divided by, this is now a plus b plus c whole square thing. We can use that formula, which will be 1 plus a square c square plus b square d square minus 2ac minus 2bd minus plus 2abcd, right? This is minus sign. And plus this thing is b square c square plus a square d square and minus 2abcd. Now if I look at this carefully, and since this is this will be square root also, right? Because here we should write the formula mod z will be mod of, suppose we have z some quantity x plus eta y mod, and which will be square root of x square plus, just to remind you. So this should be square root over here, and we should have square root over here. Good. All right. So the square root in the both can be written numerator as well as denominator. Now we saw up there like mod of beta was 1. That means c square plus d square was 1. And the equation, where is it? What is it? Yes. All right, sorry for this. Uh, Here it is. C square plus d square is equal to 1. Right? So we will use that and get it and get the answer. All right. So down there. Okay, fine. C square plus d square can be written 1. C square plus d square can be written square root of 1 in place of c square plus, if I could show you, this c square, this d square together gives me 1. And the rest I'll write as it is, plus a square plus b square minus 2ac minus 2b. And in denominator, how can I write it? 1 as it is. Here we can see a square c square. I can also see a square d square. When we group these two terms, I can take a square common, and here we can get c square plus. Okay. And plus, similarly, we see we can take b square common in these two terms, this one and this one. So it gets c square plus b square in bracket, right? And 2abcd, 2abcd is gone, and minus 2ac minus 2b. Now we can see it's same this question, the numerator and denominator are same, which can be crossed out. And how will we do it? This is like square root of 1 plus a squared plus b squared minus 2ac minus 2bd, and denominator also comes same. 1 plus, here we have a squared, this becomes b squared minus 2ac. Now they can be crossed out, so square root 1, so which means 1. So our answer is 1, alright? Yeah.